Okay, welcome everyone. Let's go ahead and get the show started. Thanks so much for joining us. Good afternoon, good morning, good evening, depending where you are, what time of day it is for you. We're so glad to have you joining us today. Manufacturers have used robots for many years, but they take weeks to program, performing only repetitive tasks without the ability to interact with other machines or people. With the introduction of AI, machine vision, and kinematics, collaborative robots, or cobots, can perform complex tasks that were previously only considered possible for humans. Today, we'll be discussing how these new intelligent cobots can learn to work with people and other robots, enabling manufacturers to boost productivity, keep employees safe from COVID-19, and reshore manufacturing operations. Hi, I'm Sarah Gerke. I've been a journalist dedicated to the 3D printing industry since 2014, and now I own and operate Additive Integrity, an AM-focused editorial services company through which I work with Fabaloo and other clients in media in the industry. It's my pleasure to welcome you to today's webinar, Collaborative Robots, New Coworkers Making Manufacturing Smarter, Safer, and More Resilient, and to moderate today's conversation with Avi Reichental, Igor Korneev, Dor Schooler, and Ryan Kelly. I'd like to introduce our panelists today so you know who you'll be hearing from. Avi Reichental is one of the world's leading authorities on business digitalization and exponential tech convergence. He is an executive who led during 9/11 and through the 2008 financial crisis while serving as the CEO of 3D Systems. Avi is currently the CEO of Nexa 3D and the founder of Exponential Works, a venture investment, advisory, and product development company, unique in its collider business model of bringing together traditional mid-market manufacturing companies with transformative startups to accelerate value creation. Igor Korneev is the CEO of Cobots and an entrepreneur in residence at Exponential Works. He is a founder and CEO of Ordinal Science, a research and innovation hub for industry and nonprofits that is focused on developing impactful AI solutions that enhance the capabilities of the industry and the potential of humanity. Igor is also a co-founder and a former COO of LoadTrack, a developer of IoT, telematics, and software systems for transportation and logistics industries. Dor Schooler has co-founded 5 ventures, the most recent being Intuition Robotics. He has a passion to develop AI-driven robotics that enables the creation of relationships between humans and machines. The company's cognitive AI engine, Q, is offered to third parties, starting with automakers, to transform their products into dynamic white-labeled digital companions. Q also powers EliQ, a digital companion aimed at improving the lives of older adults. And finally, Ryan Kelly works for AMT, the Association for Manufacturing Technology, a nonprofit trade group established 115 years ago to strengthen the US industrial base through application of technology. A key challenge in manufacturing is that the pace of technological innovation outpaces industry's ability to absorb them. To help address this problem, Ryan is in the midst of establishing AMT's first West Coast facility in San Francisco, with the goal of increasing the manufacturing industry's technometabolism through educational programs, pilot projects, and stronger ties between the manufacturing and emerging technology industries. Today, we're here to chat with Avi, Igor, Dor, and Ryan about the latest advances in and applications for cobots. This conversation will be around 45 minutes long, and we really want it to be a conversation, and you're part of that. Please feel free to submit questions throughout the discussion in the Q&A form you see down at the bottom of your screen. We're dedicating time at the end of the panelists' chat to dive into those questions. And while we might not be able to tackle all of them, we'll do our best to address the issues. I'll also be keeping an eye on the Q&A box throughout, and we'll ask our experts here questions as we go. So let's get started. We'll start at the beginning. Panelists, we'd like to know, how have robots been used on the factory floor already? And what advances are coming into play for robots that can intelligently collaborate with us, with both humans and other robots?
All right, who will take the baton? I guess I can start a little bit. Hello, this is Igor again. And well, robots were in manufacturing for quite a long time, decades at this point. Majority of the deployments right now are focused on very repetitive tasks and a high volume production. Probably everybody familiar with the manufacturing lines at the automotive plants, where assembly of vehicles is probably the best example of utilization of the industrial robots. The robots right now are probably divided into two categories as far as we are concerned, the industrial robots and the collaborative robots. The major difference between them is, well, we'll get into that today, and I'll probably leave that for a little bit later, but industrial robots are built for extremely repetitive tasks, and collaborative robots supposed to be operating together with humans. But the difference actually is not quite as clear today. It mostly has to do with safety as opposed to the degree of collaboration. So I'll leave it there and pass it on to somebody else who wants to talk about manufacturing.
Yeah, let me jump in and just expand that. You know, in addition to the traditional manufacturing and collaborative robots, we are seeing also the emergence of service robots in hospitality and in hospitals and in airports and in even certain department stores. We're seeing the emergence of companion robotics, and obviously with the help of massive e-commerce, we're also seeing all of the fetch robotics technology also around us. And so we are wading into a next generation, if you will, or a robotics, I don't know if you want to call it 2.0, 3.0, or 4.0, but we're going to be interacting and collaborating with robotics of all kinds more and more every day.
Dora, I'd love to hear your thoughts on how people are already interacting with some robots.
Yeah, so for people that don't know intuition robotics, we're not in the manufacturing space. So I have very little insight to add there beyond us being a customer of great manufacturers that help us build our products. But I guess building on Avi's point, definitely if you look at robots in general, up to a few years ago, I guess we would look in the industry and robots to do the 3Ds, things that are dirty, dull, or dangerous that humans don't want to do. And when we talk about interacting between humans and machines, it is no longer that. It's about something else. It's about amplifying the human. It's about the AI being a counterpart to the individual and building a relationship with them, which is built on empathy and built on trust, with the goal of helping guide human behavior towards meeting certain goals and changing certain behaviors while providing kind of an expert view. And it's really interesting to see. I mean, on one end, if you look at us driving a car, right, in today's cars that have ADAS in them, advanced safety features, the car essentially lets us drive the car until it gets dangerous, and that's when it takes over. Okay, that's when the car will apply the brake or correct the lane or do whatever it needs to. So we can drive as long as it's safe, but it will take control when it's dangerous. Same thing with autopilots and planes. But those are all kind of utilities. I think it helps us unframe where the technology is. It's at the point where it's better than human in discrete areas, in very certain areas. It is better than human. It's more precise than human. When you go to the interaction side, that's where psychology happens. That's where we are no longer a predictable machine, all right? And that's where we operate. How can we influence human behavior? How can we help people get to where they need to go to meet certain goals, to stay healthier, to have their social needs met, of creating interaction and on feeling acknowledgement? And I'm sure we'll get down to some of those things during this discussion.
Awesome. I'd like to jump in a little bit, kind of midway through some of the questions we had ready to discuss and get into some of the points you just raised, Store. So is a robot or a cobot, is it a tool or a coworker? What do we need to consider about the human emotional response to a working environment that has robots, that has cobots, that has people? How does that make us feel? Igor.
On Moore's point, just a bit here, you know, in manufacturing, the robots and people have been traditionally separated quite literally by the cages. The industrial robots are dangerous, they're fast, they're difficult to program, and they're not aware of their environment. They're essentially blind, they're deaf, and they're kind of stupid. So for that reason, you want to be as far away from them as possible. That, of course, that is okay when you have repetitive tasks in a manufacturing floor. But if you want to have robots and people working together, you have to have a completely different environment. The safety of the cobots have to be such that they cannot move too fast and hurt people. That's one of the primary functions of collaborative robots. Be aware of anything that they're touching and feeling, and stop their emotion if they come in contact with a person. But that's unfortunately where it ends right now. There is no awareness of sight. There is no awareness of sound. So the robots are just that. They stop when they hit something, essentially. And although they're not going to hurt the person tremendously, it is still an unpleasant experience. And beyond that, because of that traditional separation between the robots and people, there is a certain distrust in the manufacturing floor between the workers and the robots themselves. So as manufacturers right now are going into the development of collaborative robots, there is significant thought put into the idea of how to make them look and how to make them move in such a way that is a bit more friendly in order to bump up that acceptance from the workers and start perceiving those robots as a coworker as opposed to just a tool.
Yeah, I think, Sarah, that maybe we should ask not the either or question of, you know, is it a tool or is it a coworker, but how do we communicate and interact with technology, and in this particular case, collaborative robots in our lives and in our work, because these are going to be sophisticated, interactive, collaborative tools and machines. Now, we know that, and picking up here on what Dor said, there is a great deal of psychology in how we are guiding, training, collaborating, communicating, not just with each other, but with toys and tools and machines in our lives, right? We develop relationships, whether we are cognizant of it or not. We develop relationships with various objects and tools in our lives, such as cars, for example. And understanding the psychology and unlocking the ability to intelligently communicate in an environment in which we're increasingly going to have more and more semi-autonomous and fully autonomous robotic devices in our lives is at the heart of how do we unlock productivity and wellness and success in a society that will increasingly employ and deploy technology for the betterment of humanity. And we're not necessarily here on a competitive or a collision course. We're more on a course of how do we, to borrow from Ryan, metabolize this reality, and how do we train ourselves and train our collaborative robots for this new paradigm of collaboration, because they will, in essence, become our co-workers, and we will be developing a relationship with them in the same level that we develop a relationship with other objects in our lives.
Yeah, I find this a really interesting point of discussion, and just it seems like a key point so far in our discussion is, are cobots actually collaborative? And as Igor said, no, really what cobots mean right now is they're safer. And we have this this idea that we could sort of establish some kind of emotional relationship with these robots, but we're definitely not anywhere close to that, at least in the manufacturing sector. I think some of the service robots that we've been talking about, and so the Doors company create, you kind of see what that vision looks like, but it doesn't look like anything we have on the factory floor today. And so, you know, one way that we could look at it is sort of from whose point of view are they generating value, or are they collaborative? From the factory owner's point of view, it's really sort of obvious where the value of robots come from. They're faster, stronger. They do the dirty, dull, and dangerous tasks that humans don't want to do, and they do it with sort of like higher output. So from the point of view of productivity, sort of the argument for why you want robots in your factory is pretty clear, and that's been growing. But with this sort of new area of collaborative robots, with robots that you might actually collaborate with, at sort of what level is that collaboration taking place? You could say just like the purely physical level, where you could take something like an exoskeleton or a pick and place robot, and you could say that, oh, this robot is actually maybe helping me with my job. It's taking off some tasks that are hard for me. You're making it easier, making me more productive. But at sort of what level would a robot need to collaborate or interact with a human where it's actually seen as being truly collaborative, where you might actually establish that emotional connection? And it really seems like they need to do more than just not knock you over or kill you when it hits you. It seems like they need to have some more ability to have awareness of their environment. And it needs to actually understand where sort of the trade-off of sort of human responsibilities and capabilities and robot capabilities and sort of strengths are. There is this ongoing debate, and I don't know if it's really just a portrayal in the media of like, are robots going to take our jobs? But really up until this point, there's been like a real clear division of labor of what robots do really well and what humans do really well. So it seems almost a silly argument. And I think what's sort of interesting, especially with the sort of the different vantage points of the speakers on this panel, are like, well, where might the new divisions of labor or the areas of collaboration be as robots get a little bit smarter and a little bit more capable to actually interact with humans in a factory environment?
What I can maybe point to, and people in the manufacturing space might want to look at, is some of the very interesting research that was started in academia, specifically at the Media Lab at MIT, in a field called HRI, Human Robotic Interaction. And if we are imagining a world where on the manufacturing side, where humans and robots are working together on more complicated tasks that are less repetitive, more specialized, maybe not in mass scale, and so on, or where the human needs the help of the precision of the robot to reach certain places or do certain things, it can lend us a bit of a lens to look at the research. So I'm probably butchering it, but there was one really, really interesting body of work by Guy Hoffman over there, where they put a whiteboard and they gave a human a piece of text to copy it. And the room was dark, okay? And all the robot did was light a flashlight in the right space. They had two versions of that experiment. One, when the robot was precise. It waited until it had 100% certainty, and then it took action. So when the human puts the marker on the whiteboard, the lights come off and gets on that spot. And the other was when the robot was predictive. It took chances. It tried to guess what the human wants to do. And it was wrong sometimes. It didn't wait for 100% precision before it acted. But it tried to anticipate, gave the human the feeling that it's anticipating the user. And what's remarkable is how the subjects explained their experience. With the first one, they said, it did only what it's supposed to do, which is kind of like the definition of a good machine. Did what it's supposed to do. There were no bugs, it was accurate, that's success. But on the other one, it wasn't an it was a he or a she. and the subjects talk about teamwork, of working together. And she anticipated me, and we were a team, and I felt like she helped me get the job done. And all these really strange things when you think about a flashlight on a, on a rotary motor and an on-off button. That's the technology here, right? So I think, you know, we are so wired to build relationships. We're so wired to like project into an animate object and inanimate object. Think about you guys that have pets, how much we project into them. Or if you ever saw what inspired our product design for LEQ is the Pixar animation, when there's like this big lamp and little lamp and they're jumping around, and in our mind it's baby lamp and mommy lamp having a moment, but in reality it's a lamp, an animated one, moving 26 degrees in a certain direction. I mean, there's nothing there. So I think to get this really done well, we need to understand what humans' tendencies are and what motivates us and what we project and what we need, the feedback we need to give us kind of little boosts of motivation to get things done. And I think what we found on our side is need anticipation, acknowledgement, empathy, trust. Those are things we don't usually associate with robots, but actually we are working really hard on to put in our product. And when people explain their interaction with our products, those are the words they use. I think those are necessary building blocks in order to build true collaboration between humans and robots.
And you can see, to your point, Doran, I want to tie it back to what Ryan said. In manufacturing today, if you get close to the people that are on the manufacturing floor, you'll find a lot of interesting things. You know, one is many name their machines already and their lines. They give them names. Two, they have a love-hate relationship with those machines. You know, some machines run better than others. And so you can tell by who is assigned to which machine, you know, their entire demeanor and emotional state, you know, may be somewhat altered, you know, once they find out, you know, which machine they're going to be working on or which line they're going to work on. So we know that to be the fact. What we have done in cobotics, you know, through primarily the technology and psychology, is we realized from the get-go that we need to create a new protocol and a new way to communicate. We need to give higher level of intelligent machine vision to, you know, to our operating system. And we need to understand the human condition of how to minimize the degree of expertise that is required to interact, and how to humanize the protocol of communication, or in our case, the protocol of assigning tasks to a collaborative robot, and at the same time, the predictive intelligence of a collaborative robot to begin to anticipate unpredictable situation. And that is where we see, if you will, the real opportunity to create this new human-to-machine protocol of interaction, communication, and in a trusted environment or in a trusted relationship.
In the manufacturing today, oh, I'm sorry, Sarah. In the manufacturing today, what I see is a lot of tasks are actually, many tasks in the small and medium-sized manufacturers are executed by people still. And the collaborative robots are beginning to take place on those assembly lines typically, but they're still performing discrete works, discrete jobs completely away from people. Station 1 has a person, Station 2 has a collaborative robot, Station 3 has a person. But many of those assembly tasks actually require 3 hands. So why can we not bring together the person and a collaborative robot exactly onto the same station and execute the same job faster? Well, all the items that we have discussed so far, ability to anticipate what the person is going to be doing and respond to it, is exactly what has been missing in the collaborative robot so far. As people, we can be remarkably consistent, but we are still not hitting the millisecond consistencies and millimeter precision that robots expect. So how does a collaborative robot adapt to all of that? Believe it or not, it is actually a very difficult problem in robotics. It is solved, but not necessarily on the manufacturing floor today. And at Cobotics, this is what we are seeing as the primary objective of the next stage of increasing that collaboration between people and robots, where a robot essentially observes the person, understands when a task is completed by the person without somebody having to hit the button for the next task, immediately respond to it by, let's say, placing a screw and tightening it, and then waiting for the next task, grabbing maybe a tool and providing it to the worker in order to complete the assembly tasks in one go, as opposed to in 4 separate stations. So practically speaking, this is the next thing that we have to accomplish. And we're already starting to see this at factories, but that development is not quite there. But what we also see is that in examples that of assembly lines where people and collaborative robots are working together, the acceptance of collaborative robots has been going up and increasing further as well. So there is a movement towards it.
Great. Igor, you actually already addressed some of the points in a question that I was going to bring up that's come in through our Q&A box. But I'd like to pose it to everyone here for just a second to build on some of Igor's thoughts. Chris asks, what are some specific use cases for collaborative robots, and what are the considerations for the human-robot interface to satisfy the needs of these use cases?
Yeah, this is an excellent question. Maybe we should go back a step and quickly share how Cobotics came about. So Igor and I have been working and collaborating on quite a few projects for the last 3-4 years. And one of those was a very discreet manufacturing end-of-line inspection assignment in which we sought to implement some machine vision and AI to create a higher level of inspection that was not exactly possible to achieve with a human eye. And so we did it, and we developed the machine vision, we developed the algorithm. It was an amazing project and it succeeded, except that it was only discrete for very small impellers. And the next assignment came, and it was for a much larger injection molding part in a tier 1 automotive supplier. And so we said to ourselves, we read so much about all these collaborative robots, it must be really cakewalk to get one of them and integrate it with our systems, and maybe we'll spend a couple of weeks and we'll call it success and move on. We purchased, we drank the Kool-Aid. We purchased one of these collaborative robots. We discovered that it wasn't collaborative at all. And it took us many, many months to get this particular robot to function at the level that was indicated in the scope of the manufacturing process. But we discovered a few other things. We discovered that there was no interface or a layer of operating system that one could interact with quickly. So we developed it. We discovered that the kinematic engine in that particular robotic device was deficient to the kind of efficient and anticipatory and predictive movements that we wanted to do. So we corrected that. We also discovered that once you have a collaborative robot and you actually give them the vision and the hearing and the intelligence to be adaptive and flexible, they can do a lot more than just inspection. And they could be in the afternoon deployed to do another task altogether if you could easily communicate them and you don't need the skills of a coder or a super manufacturing engineer. And that's kind of how we came about and how Cobotics was born. We did a few of these deployments, and eventually we realized the world can benefit from a Cobotics OS, operating system.
As I'm sort of overhearing the discussion, what's occurring to me is the sort of, in collaboration, there's this kind of feedback loop when sort of one mind or one sort of person talks to another person or another sort of agency, and robots, and sort of the historic, this way we think about them, they sort of say, I follow your instructions exactly. And so it's really on the programmer or the operator of that robot to be able to provide really specific instructions of what you want that robot to do. And it seems like a lot of the progress that we've made in industrial robotics today says we're making it really easy to give instructions to this robot, to the point now where you can have some pendant and you can just move the robot the way that you want it to move. But it's only going to do that exact thing again and again. And it seems like this a big transition that's about to happen is sort of including more sensory awareness, and also some type machine learning type capability, so that now the robot can say, okay, I think I know what you want me to do. Let me give it a try. And over time, I'll learn from my mistakes. When you tell me I'm doing something wrong, maybe I'll get a little bit better at sort of achieving your desired outcome as I go through the iterations. But it seems like what we really want, and sort of maybe where this sort of thread goes in the future, is to say, well, I think I know what you want. Let me make some suggestions though of what make this process a little bit easier. And so we've hit upon a couple of things. One is this sort of this language and our ability to communicate our intent to the robots. And I think that's something that Cubotics is really hit upon. We're trying to make that it really is as easy as possible and trying to find some common language. You see CNC operators today, they kind of put their hands on the machine and sort of, this is how they sort of get this feedback now. They kind of have this sixth sense of understanding the machines. Now we're seeing
haptic feedback.
Haptic feedback. We're also now, because of all these sensors, actually getting the data. And so this is what the feedback loop look like today. But I think to get to where we want to go with some of the big ideas that we've been talking about, there really actually has to be a more sort of natural capability for the sort of humans and the robots to have a dialogue. Is that the right word?
But Ryan, I want to really go to Dor. Sorry, Sarah, that I'm kind of I'm itching to get to Dor here and the work that he's doing, because there is a great deal of precedent, both on the technology side and the understanding of the human condition, that suggests that kind of language and dialogue is easier to achieve than we think, that we ourselves as humans, our responses and the way that we learn and train is fairly predictable, and that in Dor's field, we already took it to the next level, in which machines are actually training us and guiding us how to do what we do better, safer, and more efficiently. So Dor, I want to hear from you, because you kind of unlocked the code already with intuition robotics, at least in two fields, with the elderly and now in semi-autonomous driving.
I think you're giving us way too much credit, Avi, but we're definitely trying. And listening to Ryan, he kind of like described the architecture of our agents. So kind of how do voice assistants work? Okay, very much like robots in the field work. They wait for the human to give an instruction, right? Alexa, turn on the lights. So it does nothing until you give that utterance, and then it will parse that utterance and put it on the relevant skill, and then execute that. And it will always be the same way. It will always be the same thing. Doesn't matter if I tell it every day, 100 times a day on different Alexa devices or whatever, Alexa, turn on the lights. Always be the same. If Avi does that, it will be the same. And the architecture move, when you move to what we call a digital companion, is relatively radical. And we're still building that, but I think we've generated very, very interesting proof through our work over the last 4.5 years with users and all of that. And that changes the premise. The premise is that the agent, the machine, is the one that initiates the interaction. And it's only able to do that because of the type of advances that Igor was talking about before and that Avi was talking about on having the machine the ability to hear and see and sense. So once it's able to do that, the machine or the agent can now build a relatively decently accurate representation of the world around it, the state, okay, the state of the world. And if you add to that goals, which is the internal motivation of the agent, which is what fuels it, right? The agent is essentially a purpose-built machine that's trying to get a reward signal to specific KPIs. And in the world, for example, of our work with the elderly, which is becoming super relevant in these days of COVID, could be many KPIs, 20, 30 KPIs. A lot of them compete with each other. Don't annoy the user is an important KPI. Push the user to eat healthy food and to move around and not be in front of the TV are 2 other KPIs, which are contradictory to the first one. And add to that another 17 KPIs, and you get a sense of what I'm talking about here. So what the agent does essentially is continuously builds a view of the world, of the state. It continuously maintains a user model of everything I know about the subject, Dor, for example, his name, his likes, what motivates him, what's his personality profile like, does he respond well to humor or to fact or to persuasion, and maybe differently after certain type of causality events that influence that. And we look at the goals, we look at the state of kind of where we are on those different KPIs, and the machine runs a prediction. If I interrupt now, will I have a high degree of success? And if so, which is important to me because maybe I'm really hungry in this goal and I'm relatively satisfied in that goal, and maybe it's lunchtime and the user needs to take their medication, so there's a higher priority for a safety related or a health related goal. And all of that gets stuck around in the algorithm and it comes out with an answer: do nothing or do something, and from that something do that. And then it looks again and says, okay, let's say I want to remind somebody to take their medication. Out of all the different ways that I was pre-programmed, no magic here, pre-programmed in advance to try to convince somebody to take medication, which was the most effective one that will work on this specific user in this specific time, given everything I know about the user and given the state. And then it will spit that out and what you will see as the end user is essentially hear a sentence that a creative person pre-wrote, of a conversational designer pre-wrote. You will see a movement, in our case, which feels natural. You'll see a light pattern, you'll hear a sound effect or something on the screen, or a combination of all of those, which will hopefully move you in an emotional way and motivate you to do what the machine wants you to do, which is to take your pill, because it's important for your health that you do so. Anyway, sorry for the long explanation, but that's the paradigm shift that's now possible because of sensing and because of more modern decision making, and also because of a lot of advances in behavioral psychology. Whereas Avi said, we are sometimes predictable and we can be motivated, as advertisers have figured out a long time ago. If you push our buttons, we will respond in certain ways. So you put all of that together and you start getting a very, very different interaction between the human and the machine.
Okay, Dora, I think that brings us to a really good point about bringing these machines into our lives, bringing these robots into our, our ways of working, our ways of functioning. And if we take that kind of thought and move that back over to the manufacturing mindset, Ryan, I'd love to hear your thought about what the human side of that looks like, bringing the robots in. How can companies make the shift into establishing smart factories? What do people need to take into account in terms of technology implementation, processes, costs, other considerations? Basically, what do we need to make robots happen?
Sure. So I think that there's sort of what is possible in the near term, and then what is sort of needed to enable the type of scenario that Dora's talking about, which seems somewhat like if you think about all of the variables that he discussed within this context of elderly care and what it is that the sort of agent needs to sense and respond to, and he mentioned that there are dozens of KPIs. There's a question in our Q&A really talking about, can you speak to the role of the sort of the digital twin? Well, this is actually precisely what it is that we're talking about. In order for this agent or a robot or some AI to reason and react in this way that we want, it needs to have some idea of what the world looks like in a very sort of deep sense of that. So if you think about the factory as opposed to sort of this elderly care scenario, it could be that it's a lot more complicated. There's probably a lot more people running around. There's a lot more sort of machines that are sort of doing things that sometimes are easy to predict, sometimes hard to predict. But the reality is that the sort of the factory environment is very complex. They're dynamic systems with a lot of things going on. So I'd say to get back to your question, Sarah, if we're looking at the sort of the distant goal, one thing that we're going to need to achieve the sort of scenario that we're talking about is a lot more sensors, or a lot of ability for sort of the collect information so that artificial intelligence can have a more detailed view of what's going on in order to make better predictions about how it is that you want me to respond in order to move certain KPI forward. So what might some of those KPIs in a factory be? You take quality, then what are all the factors that are going to influence quality? How can you give a computer some idea of what those factors are and get some ability to say, hey, like I noticed that machine is making a strange vibration. I know that that affects quality. This is something that you might want to look at. Or, hey, Barry, he's kind of slurring his words. I think he might be drunk, and sort of my sort of understanding says that when Barry's drunk, he doesn't make as good parts as he does. So, I mean, that's kind of like a silly example, but looking in order to create true collaboration between sort of machines and people, what's needed is a much better, more accurate and robust understanding of what the sort of the world looks like in almost a real-time basis. There's a big distance between where the factories are today, where there's still a lot of paper flying around these factories and the machines aren't really connected and talking to one another, and where we want to go. But I'll say, what are the big barriers preventing us from taking the first big step in that direction? I would say the first is there's a lack of, we call it the skills gap. Manufacturing as an industry has trouble attracting the best and brightest minds to it. The average age of the people working in factories today is probably over 50. These people are retiring, and there's not young people that just like know stuff about computers that are willing to take their place and can sort of imagine what this new paradigm is going to look like. So that's, I think, one of the key things that need to be addressed. It's probably easier to get a bunch of smart young people that can imagine a different future, get them into the factories, and then they'll just go crazy with all the stuff that we're talking about because they find it really interesting and they might have the technical capability and the courage to do it. So that's a big thing that we need to do. We need to figure out how to get smart young people into these environments to deal with these kind of problems. The second is just investment. Robots are really expensive. Even today's cobots are still really expensive. In the United States alone, where most manufacturing operations are small businesses, we saw sort of the pattern of investment stop, this sort of big capital investment stop around the time of the Great Recession, and they never really picked back up. And when you talk to manufacturers today and you say, I'm gonna give you $100,000, where are you gonna invest it? They have a bunch of possible things that they could invest in. They could invest for training for their people. They could invest in a new CNC machine. They could invest in a new ERP system. They could invest in expanding the footprint of their factory. There's actually no shortage of areas for them to invest. And so finding ways to either bringing the costs down for these innovative technologies, or subsidizing in some way the ability to sort of make these big investments is going to be really important. But I would say that while there's a lot of other factors that prevent innovation from happening in factories, if you could just address those two, sort of the cost of getting these types of projects done and making sure that there's the people there that can lead and drive these types of innovations, that's going to be the big catalyst to making these changes happen.
If I may add, I would actually like to expand on that a little bit. Just for the sense of scale, to program an industrial robot today to do a task takes a couple of weeks if you have a good, proficient engineer. And those are rare, it's hard to find them, very difficult to come by. Collaborative robots are supposed to address this problem, and they do. So instead of weeks, they take days to program. That's a significant improvement, but it's still not near where it needs to be, especially when we are considering the change in the manufacturing practices. Right now, the changeover times are significantly more frequent. In the mid-size and smaller manufacturers, you have situations where the same manufacturing line may be producing 2 parts in one day. So how can you deploy a collaborative robot if it takes 2 days to program it or 3 days to program it, but you have to run it only for 3 or 4 hours? So we need to find a way to do this, the programming part, very quickly. And we need to have a common language and understanding for this. And you know what astounded me this always, when you buy a piece of software in the late 90s, early 2000s, it came with a big manual that you had to read and understand and explore, and you had to learn. But now when you download an app from an app store, does it come with any instructions? No, not at all. We pick it up, we open it, and we immediately start working with it as if it is something we've been doing forever. So in collaborative robotics space, we require the same type of platform and framework that allows automation engineers or developers to build a task, a piece of software that any worker in a factory can pick up like an application, a mobile phone application, and immediately begin working with that. That's the purpose for cobotics operating system in a nutshell. Make a platform where other people can develop very simple applications that are immediately usable.
Yeah, I like to be a little bit the maybe contrarian and the optimist here. So take it in the spirit that I'm offering this. I've spent 4 decades in factories, and I find spending time in factories a lot more predictable and safer than driving a car on the freeway. There are less variables. And the fact that we are solving for level 3, level 4, level 5 autonomous driving with all of its variables, and actually also solving for the communication between us as a co-pilot and a car as an autonomous co-pilot, and how we are being trained and conditioned for that is a very, it gives me a great deal of comfort that we can do it in the factory. Secondly, if you look at the numbers, the adoption of these collaborative robots, which typically range in cost between, call it $30,000 to $60,000, is increasing exponentially year over year, particularly for the reasons, Ryan, that you mentioned, that there is aging of the workforce and scarcity of rejuvenating that workforce. If you look at it in terms of small to medium-sized manufacturing enterprises, not just in the United States, but around the world, the ROI on one of these collaborative stations typically is less than 6 months in many of the cases that we have looked at. But they also give you the consistency, the repeatability. They don't come to work drunk, like Barry that you mentioned earlier. And they have a certain predictability, which means that, pre-COVID, we already saw this trend of skilled labor scarcity, which collaborative devices solve for as well. The last thing that I wanted to say is even in paper managed smaller factories, there is a great deal of data. And one of the things that Igor and I learned, because we have worked in some 150-year-old and 100-year-old factories the last few years, and discovered that even in factories in which all of the process knowledge was locked in the heads of seasoned operators, we were able to very quickly install sensors, which are very, very cheap today, and begin to collect data and also mine the paper data, and not only create the elements of a digital twin simulation and model, but begin to intelligently understand how to bring complex processes into predictive cycles and controls. So maybe part of this, Ryan, part of the metabolism or the resistance or the harsh realities or the constraints is more a question of education. Because if you look at it in terms of the ROI, the technology, the available data, the scarcity of labor and all of that, it's probably a more urgent crisis to solve for now rather than punt it for the future.
I would completely agree with that. And it's also worth mentioning that sort of the trends are going in the right direction. I think we're seeing 30 to 40% compound annual growth in the application of cobots. So there's a question on what sort of is the price point where we might find the tipping point. It could be that we're actually heading in that direction, but this is for the sort of the version of cobots that we have today, which are still dumb compared with some of the things that we've been talking about in today's call. And certainly with COVID, we've seen a huge jump in people's interests for these types of technologies where they simply just can't have as many people on the factory floor. And so this is pushing them towards the adoption. So we're definitely trending in the right direction, accelerating the trends of the adoption of these technologies. The price has gone down. But if it can go down even further, I think we'll see it's just going to become a no-brainer. ROI is already there. My argument is that, well, right, but they have a limited amount of money to spend in lots of different areas to do it. Why would the sort of robots be more than some other technology? But I mean, if you look at the numbers, we would say that more and more people are interested, and more people are adopting it. So it could be that we are sort of accelerating in this direction.
And maybe it's not so much.
We definitely are. Sorry about that, Igor. Ryan, we are starting to run up toward our hour, so I want to make sure that we can touch on some more of the questions that have come in. Dushka has asked a couple of really great ones, so I'm going to tie a couple of those together that I'd love to see us make sure we get time for. Asking, can you speak to the latest thinking in regards to accountability for automated tasks or tasks performed by robots? Who's responsible, basically, if something goes wrong as a result of robot action? And there's a follow-up to that about ethics being part of the guiding discourse around robotics. What are the ethical frameworks for evaluating safety and boundaries? So we're looking at accountability and ethics, and I'd love to make sure we touch on those points. Igor, you were about to start talking, so I'm going to throw you under the ethics bus here.
Oh, no problems. That's actually, believe it, I have a tremendous interest in that field. In fact, I actively participate in the fairness and accountability for artificial intelligence panels all the time, because it is obviously a very lively discussion right now around the world, and there are some serious concerns around this. By the way, hello, Dushan. We used to work a few years back, a brilliant young man. A few years ago, I believe he's now in Chicago. So thank you for the question. So from perspective of AI itself, there is quite a bit of work done today to understand what is ethically allowable and where is the boundary comes in of what AI can learn on its own and how far you want to let it go. This is a little bit beyond the scope of this discussion. I think here right now we are talking specifically in terms of collaborative robots. And what does it mean if collaborative robot plans a path to let's say, navigate and put a screw into an assembly and somehow pokes an eye out of a coworker who is responsible, right? I don't know. That's a very good question. It extends to the debate that is going on right now around autonomous driving. What is the current thinking? Are the manufacturers responsible? Are the software people responsible? I certainly hope that this will never happen, period. But I'm not prepared to answer this question yet, as you know, a lot of people are struggling with that idea.
I can share a little bit from the autonomous driving area. We get invited to a lot of these discussions. Is what are we willing to accept as humans? And it's really interesting because 40,000 people die in the United States from car accidents every year. And you'd figure if through AI we can cut that in half to only 20,000 and save 20,000 lives, that would be great. But I don't think that as a society we can accept 20,000 people getting killed by software. And therefore our tolerance becomes zero. It needs to be zero for us to feel comfortable, which is an unbelievably complicated task. But I don't know anyone, we're kind of conditioned to, you know, if somebody gets run over by a drunk driver or a stupid mistake, we learned how to live with it and to accept it, but we haven't learned how to live or accept somebody dying because of a software bug or glitch. And that probably is fully transferable to the manufacturing line, right? If it's a small error that will cost somebody some money, it's one thing, it's probably a cost of doing business. But if it's someone's life that's on the line, the bar is unbelievably high for us to trust machines. And that's why today they're in cages. And that's why I visited an auto plant recently before COVID, where the entire plant was dark. All you can see were sparks from a viewing room. And as soon as we walked on the floor, the lights turned on and all the robots stopped for our safety, right? So that's one extreme. And I think we'll need to get very, very close to the other extreme when lives are on the line. If lives are not on the line, there's a lot of flexibility there.
Yeah, I would add to the question that in addition to the ethical and liability issues that we're gonna have to wrestle with and adapt, because this whole movement is afoot, you know, it's happening. It's just in its maybe deceptive stage, you know, before it kind of explode maybe into its exponential stage. We also need to kind of rethink and reshape the role of HR in a factory in which we will have these kinds of collaborations, and how do we normalize them, and how do we manage that aspect. We will need to rethink and reimagine insurance. We will need to rethink and reimagine product liability. There are going to be many fields that will be disrupted and have to be reimagined as a result of this movement as it expands. What I can say with some certainty, because I've seen this in other fields in my professional career, is that typically this kind of a technology disruption takes place over multiple years, before, sometimes a decade or more, before you begin to notice that, oh my gosh, my factory floor changed. And oh my gosh, the way that I'm driving my vehicle changed, or the appliances that I'm interacting with in my kitchen changed. And I think that the most important takeaway from this is that all of us have to be mindful, and there are plenty of opportunities here to collaborate proactively, educationally, technologically, to normalize it and to metabolize it a little bit easier. And I think that COVID is a tremendous catalyst in this field, and will be for quite some time, because forever going forward, CEOs and business owners will rethink their supply chain entirely differently than how they thought about it pre-COVID.
Avi, I wonder if I can ask a quick question as somebody that builds consumer electronics, right, and pays for it. And maybe there's an opportunity with the flexibility that a programmable line working with humans can offer, because when I look at my business, everything is just in time, right? I mean, I get paid when I sell a single unit, I ship it just in time, except the manufacturing line. I need to give 26-week lead time and do $1 million build so that the factory has an incentive to take our line out of storage, retrain people, do a 2-week run, package a huge amount of inventory, ship it where it will be stuck in warehouses for God knows how long until they get rid of it. And I need to remember to plan 26 weeks in advance to give them notice again. And if I get that wrong, I'm in trouble in either side of the equation, either on my cost of capital, on the cost of inventory, or I lack inventory to ship to customers and get revenue. Will that change, right? Can you make my life easier if we get through cobots, through collaboration, a more flexible manufacturing line that can react in faster speeds, that maybe needs, that the supply chain of that line maybe can react in faster speeds, and manufacturing can join the 21st century in allowing us to be flexible in the business model?
I think that's, well, in the first place, that's a great idea for the next panel. But because this is in itself sort of going against, what you're talking about is a completely new supply chain paradigm than the one that exists today. And because of COVID, if one good thing that has happened is that now everybody is thinking about manufacturing and supply chain. In fact, I saw an analysis of 1,000 CEO shareholder calls. Supply chain was the second most term cited, the first being remote work. So that says great, people are paying attention to it. How do we move in that direction? But I will say, to sort of give a fair answer to your question, that this discussion around cobots and the flexibility, the adaptability, the sort of the speed, going from 2 months to program a robot to 2 days, that's still not being fast enough. Can we get to 2 hours or 2 minutes? This tendency for flexibility, adaptability, not having to rely on careful planning is the exact trend seen in different areas that's going to get us from the supply chain paradigm that we have today into the one that we have, or the one that we desire, the one that says, I don't want to have to commit to building 10,000 robots and 10,000 robots only. What happens if I sell 12,000? You lose those sales. What happens if you only sell 5,000? Then you got a bunch of robots that no one wants on the shelf. So this is it. This is a big problem with big business implications, but it's going to take sort of all the different facets of that sort of moving towards more agile, more flexible, more adaptable in order for us to get what we want out of that.
Yeah, and Dor, the more specific kind of answer to your question, can some digital fabrication and flexibility and collaborative robots help in your case? I think the answer is yes, and it's going to take a little bit more than just a collaborative robot to get there. But there is this whole movement also in additive manufacturing of short, flexible series production that might also benefit. And the trade-off always is the cogs in the box, versus the cost of a complicated and expensive supply chain and inventory. And those are the trade-offs that can come into play in your case, but we can certainly offline take a look at it and give you some suggestions.
Thank you.
All right, guys, these are all excellent discussion points. And as we can see, there's a lot to talk about as we continue to see this area grow in manufacturing and personal use and in this COVID world we're all living in right now. So I'd like to wrap up by bringing together a couple more questions together into one overarching theme, and kind of do a final thoughts from each of you on the topic of education and adoption. Basically, how can we drive education? Have you seen specific strategies, educational models to promote knowledge, to promote adoption? How do we leverage these to bridge the generational gap in the workplace? And just really kind of tie up the loose ends as we're bringing cobots into reality, into our daily lives, our daily work. And there's a lot of automation that is coming up with digital manufacturing, with cobots automating, with additive manufacturing, with everything that's working to help us work together and build better, work better. And so in keeping it up with this in terms of education, adoption, and final thoughts, I would love to start with Avi. Why don't you start us off on our final thoughts?
Yeah, so I thank you, Sarah. And by the way, great panel, everybody. A really lively discussion of kindred spirits. It's enjoyable and informative. Education to me has to be taken in accordance with the audiences. We have the executives, CEOs, small business owners. They have their sets of incentives and needs and specific education on how to deploy and employ and invest and allocate resources so that they can remain relevant and competitive in a post-COVID manufacturing landscape that is likely to change a great deal with all the discussion about nearshoring, onshoring, resilient supply chain, and so on and so forth. Then there is the question of how do we begin to make it digestible and friendly, and how do we normalize this new paradigm of more cobotics in factories around the world, and what kind of education is required to achieve that. And part of it may not be education in the conventional sense. It may be more in the interfaces, the operating system, the examples that Dor gave previously on how the car is really training us, you know, when and how we need to co-pilot the car while we reserve the most complex and dangerous activities to the vehicle itself. That might shape and inform how that level of education happens. And on the other extreme is making it really easy, like an app, so that you don't have to learn, you instinctively and intuitively can interact with it. And all of that is part of what I think all of us are working on individually and collectively. And certainly there has to be some market education and the understanding of the power of the convergence of all these technologies like robotics and sensing and 3D printing and ubiquitous connectivity and AI, how all these technologies and digital twin, how all these technologies converge on the factory floor, and how does one derive value, quality, performance, profitability, and wellness of the business and the people as we understand that convergence and how to harness it.
Okay, fantastic. Thank you, Avi. Ryan, can we go toward your final thoughts on these areas?
Sure. Well, I think that what's happening now isn't really working or isn't really satisfying the demand. I mean, data from the National Association of Manufacturers says that there are currently over 500,000 jobs available in manufacturing. And what is the reason for that gap? It's because they don't have the skills needed. So there's like a couple things that need to happen. One is that we need to start early, and we need to sort of instill in young people that that these jobs aren't dirty and low paying and not prestigious in any way. The fact of the matter is that the manufacturing industry provides a really interesting career path that does pay well and actually is really aligns well with young people's interests in terms of wanting to make some kind of social impact. If you're interested in green technologies, manufacturing sector is perfect for you because that's where those innovations are going to take place. So there's this is kind of changing the mindset of young people is a big thing that needs to happen. It doesn't really seem to be happening in the four-year universities. Where it could potentially happen is in the community and technical colleges. These skills don't take years and years to develop. I mean, certainly we need people going to get masters and PhDs to really drive innovation because that's where innovation seems to happen. But when it talks about actually cultivating adoption and getting these products into the field, it means probably going to a 6-month-long program and not a 4 or 8 year education path. And I think, you know, another thing is actually just getting industry to sort of drive it. Industry needs to come together and say, these are the skills that we want, and go one step further and say, and this is how we're going to cultivate them. These are the sort of certifications that we can all agree on that's important. And then you can start to deploy those in online or through community and technical colleges. So like a good example to look at is Google has partnered with community colleges and some other government programs, has put millions of dollars up to create IT people. There's also this sort of demand for people that are working in IT. Google said, is this an important enough issue to us that we're going to pay for all these people to get these certificates so that they can sort of go into the workplace and make IT better. You can see how that benefits Google too, right? Because they're probably going to use a lot of these Google products, but it could be the same way for all the robot manufacturers. They could sort of cultivate something similar as a way to get the skills needed to fill those jobs. And then in turn, people will buy more robots.
Wonderful. New ways of thinking definitely require new ways of approaching and training and educating. Dor, can we go to you for your final thoughts on these topics?
Sure, I guess 2 of them. One is definitely open up your imagination on how the relationship between humans and machines is changing, and you look at what we're doing, what some other companies are doing. It's still a work in progress, but it is coming, and I'm sure it will hit manufacturing line. And the second one is more of just a pondering thought, which is not fully formed, but listen to what Ryan said now and listening to what he said before, I actually hear a lot of opportunity. And I wonder what will happen if a software-led company, if a tech-led company would open a manufacturing line and hire some of the best skilled engineers in Israel or in Silicon Valley or wherever, and kind of do to the manufacturing business what Elon Musk did to the car business of having a computer on wheels, right? That happens to be a car, but it's essentially a software company and a design-led company. And everything you're mentioning seems to me like an opportunity for an industry ripe to be hit by, how did I think it's Ben Horowitz that said once that software is eating up the world and cars are on the menu. Well, maybe software is eating the world and manufacturing is on the menu, because it's exactly the type of things that are ripe for a major disruption. If it's a lack of technical skill and a shortage of manpower, but the need is there, and the need to be more agile and respond faster is there, and there's actually money on the table. What if Google will build a manufacturing line? What would it actually look like? And I don't know. That's just kind of the thought you left me with. I'm going to ponder that for a while. But if I was
well, I'm glad, because it is the biggest opportunity, and I see Avi smiling too, because we know, and we're trying to get everybody else to realize that too. So it looks like, at least with Dor, we've achieved our mission in some way there.
But it's not, I don't think those things are evolutions. I think those ones are revolutions. Somebody comes into this with a white piece of paper, how would he redesign the line if he can get enough scale? And kind of like what Uber did to a taxi company, right? It's very different. It's not an incremental change of hiring an IT guy to help the taxi company. Anyway, that's what you left me with. I'm going to ponder that for a while.
Okay, fantastic, Dora. Thank you so much. And Igor, I'd love to hear your thoughts as we wrap up this very lively discussion.
Sure. In terms of education, specifically from the perspective of how can we make robots more ubiquitous and more friendly, my answer was always, until about 4 years ago, was more mathematics, but it changed. And the answer today is more mathematics and psychology. Those two subjects were kind of divided into completely independent magisteria and never to be crossed or touched. But what Dora is doing today is, I think, is a marriage of both. And I think that is the most important paradigm that I have seen in the last decade. How to make those robots intuitive, how to make people believe that those robots are looking after them. And I think fundamentally the two building blocks are those, mathematics and psychology. And from perspective of manufacturing, what is the practical next thing that we need? I think we need a common platform. And a simple example, look at the headsets. Look at what we had with phones, mobile phones in the early 2000s. Hardware manufacturers dominated the market. They all had their own proprietary operating system. It was impossible to make an application that was actually practical and useful. It was just a pain in the butt. But iOS and Android especially came out with a platform that allowed you to program applications, develop applications quickly, and also distributed them. And we all know an absolutely astounding change that caused in business and our personal lives. Not many people were able to predict it even a year out. The fundamental shift in thinking about business and about our personal life management that occurred. Why manufacturing is different? It isn't. We are in exactly the same position today. Every robot manufacturer has their own proprietary hardware, proprietary operating system. They don't talk to each other, and everybody's struggling to implement one use case at a time. Why don't we just make it all universal and let everybody jump in and use their brain power to make something that is easy to understand, implement, and put into a factory? So I want to work on that.
Fantastic. Thank you so much, Igor, for sending us out on that note. It's a good way to keep looking ahead. So I'd love to thank all of our panelists today. Avi, Ryan, Igor, Dor, thank you for sharing all of this. We still see comments coming in. This is inspiring stuff. It's giving everyone a lot to think about, a lot to talk about. And obviously this is a conversation we could all very easily continue. So we've gone a little over the hour that we'd planned on, but it's impossible not to. There's so much packed in here. Collaborative robots, a collaborative future in technology and psychology, and basically working together and creating the next phases of not just manufacturing, but I guess the way we're living life and interacting with the world, with robotics, and how they interact with us. So thank you again to our panelists. Thank you to all of the attendees who've joined us today and who are joining us later on the recording. It was great to have you all, and I know we all look forward to continuing this conversation. Have a fantastic rest of your day, and thank you all. Bye.
Bye, thank you.